Right, so I thought I'd do a quick video here on how to configure and use the software interrupt capabilities on the nRF52 series. Just a little bit of background on why you'd want something like this. So traditionally, you use hardware interrupts, whether it's through a peripheral or through whether it's through some memory or even through DMA capabilities to do certain tasks as a priority over what's happening in your main application code. There are, however, circumstances where you'd want to have a similar sort of interruptible behavior, or interrupting behavior rather, that's triggered via software. Most modern microcontrollers will support this to some extent. So you might want to aggregate a number of events happening via several hardware interrupts, for instance, as an example, and have that all combined into a single software interrupt once all of those aggregated events have occurred. So you can use a series of flags, and then once all of those conditions have been satisfied, you fire off one software interrupt to handle whatever event you need to be executed after those aggregated events have occurred. So we're just going to do a really quick, simple demo here where we're just going to use a simple delayed trigger in the main loop to fire off an interrupt service routine rather, and you can expand that however you need to for your specific application, but I'll keep it simple for the purposes of this demo. So we're just going to go into the examples directory here in the SDK, and then open up peripherals and grab the template project as a starting point. And we'll open that up. I'm using the PCA 100056 for this demo, so we'll use that SES project. And just some housekeeping, just going to delete the crypto libraries here since we're not going to be using them. Alrighty. And only other thing that we need to check is that in the configurator we have our SWI peripheral enabled. Let's make sure that's checked, and then we're good to go. I'm just going to delete all the leading comments, make some space here. So to get started, we're just going to include a couple of files. So the first one we're going to include is the nRF52 SWI header, and we're going to include delay as well. So if you see my keyboard repeatedly pressing like that, it's on its way out and it needs to be replaced. Oof, it's getting bad. Okay, so we've included those two files, and then we're going to now define our SWI peripheral instance. So this is the handle for the SWI object that we're going to be initializing. So then we're going to go down to main here and call the function nRF52 SWI alloc, and then pass it the handle for the SWI instance. And then we're going to give it a handle for the software interrupts routine that we're going to be using to perform whatever task we're going to. So I'm just going to call that SWI event handler, and give it a low, well, it's the only interrupt really that we're running, so we'll just give it priority low. Oops, it's getting really annoying. Priority low. And we'll write our interrupts routine here, so void, grab the handler name, and nRF52 SWI, and this is the same type as up here, and we can optionally also pass flags to this ISR as well if we choose. I'm not going to in this example, but I'll point out where you actually will be able to exercise that. So this is pretty much all of the configuration done at this point. You have it being initialized, and then you have your handler vector. So for this example, I think what we'll probably do is just flash a basic LED, and I'll set that to update or toggle every X number of milliseconds in the main loop here. So I'll go ahead and define the LED pin here. nRF GPIO pin map, and I'm just going to be using LED1 on this dev board, which is on port 0 pin 13. And we'll go ahead and define that as an output. Output LED. Cool. And last thing we're going to do is call the trigger function for the SWI, and all we need to do is pass it the instance, so SWI inst, and then we're going to give it pass it no parameters, and I think we'll set a delay on that, so nRF delay milliseconds, let's do half a second delay. And in our interrupt, we're just going to toggle our LED. That's that pin. So what will happen here is once we've initialized the software interrupt, every half second we'll trigger the software interrupt, and then this ISR will catch that and then toggle the LED state. That's the idea. So let's just build this, make sure we're not getting any errors. And we're good. Alright. So I'm just going to pause the recording and get the camera set up on the board, and I'll resume once I've done that. Alrighty, and we're back. So I've got a fairly crude setup here, so apologies. We're just going to build this, which we've already done, and we'll go ahead and upload that to the target. And I'll stick a breakpoint in this software interrupt handler just to start with, and we'll go ahead and run the code. You can see our LED is turned on there, and if I run it again, we'll recapture it half a second later, and we can toggle it that way. So if we remove the breakpoint, you can see our LED flashing. Cool. Well, hope this was of some help to somebody. Catch you in the next one.